In this class, we're going to consider variables. And variables are important when you're working with algebraic expressions and working with mathematical formulas. And we're going to look at formulas in the classes which follow this one. So by definition, a variable is a term in an expression which can vary. It doesn't have a fixed value. So these are all expressions. We're going to look at them in a moment. And you can see that they've all got letters, and it's the letters in these that represent the variable. So we represent variables mathematically using a letter, because it can't be a number, because if it was a number then it would have a fixed value and it wouldn't be variable. So it can be any letter from the English language. Sometimes it's a letter from another language, but often in mathematical expressions or formulas we use X. Not quite sure where that comes from. It's got some historical context and background, I guess. But it doesn't have to be X. It can be A's and B's. It can literally be anything. And sometimes we even use letters from the Greek alphabet. So in mathematics, we make quite substantial use of Greek letters. So for example, the letter theta is often used to represent angle. So sometimes we use particular variables, particular letters, particularly Greek letters, to represent specific types of thing that we're allowing to variable. It's still a variable, can still take on different values, but it has maybe an added meaning as well. Anyway, that's maybe a little bit for the future. Let's just have a look at these guys here. So we know that the letters represent the variable. So here we've got an expression. This is called an expression, 2x plus 3. In a class further on in this series, we're going to explore a little more what mathematical expressions are made up from, and we've got some terminology around that. But for this class, let's just focus on the variable. So there's only one variable in this expression. You'll notice in this expression you've got an a and a b, meaning that there's two variables. It can be either way. You can have multiple variables or only one. It just depends what the situation is. In this example here, this expression only has one variable, but that means that if you wanted to let that variable represent an actual number, the expression itself would take on a different value. So this is the beauty of a variable. It allows flexibility. So let's say, for example, we wanted to let that x, which is our variable, represent the number 1. Then this here would be 2 times 1 plus 3. So we would evaluate that expression and it would come out to be 5. But if we wanted to let x be 10, for example, then 2 times 10 is 20 plus 3 is 23. So different x values, different values of the variable will lead to different outcomes. So that's really the beauty of a variable. We can say that all of the numbers that we are going to generate by different x values are generated by this expression, and this expression really works because it's got a variable in it. Okay, so that's just that little example there. This one, like I said earlier, is an expression which contains two variables. That means if you started to substitute in values here, if you wanted the a value to be some numerical value, you would need to also let the b value be some numerical value as well. You sub in those combinations of a and b, and then you can work out what this gives you. But the point here between this example and this example is just the different forms that variables can appear within an expression. So here the x was multiplying to the 2. Here the a is being squared and multiplied to the 7, and then this b is just being added to that. So these variables can appear at different places within a mathematical expression, but they're all variables. They're all allowed to vary by definition. This here is called a mathematical function. It's a little bit like a formula. It's like a fancy version of a formula. This is a formula. This is just kind of a made up. I just made up this function. It's called a quadratic function. You're going to learn about them later in this course. It's called quadratic because of the x squared term, but this notation here allows us to work with a variable kind of like I did over here, but in a more formal way. So let's say that I did the same thing that we did over here. Let's say that I wanted to let x be 1 and then let x be 10, so letting the variable actually be those particular numbers. This notation here allows us to write f of 1 like that, which is just kind of equivalent to saying I want x to be 1. Here I'm just saying x is 1, and then you would just put that in here. So you would get 1 squared plus 1 plus 12, add that all together, and that comes out to be 14. And we could do the same thing for the 10, f of 10. This is a little bit beyond what you need to know right now on variables, but it's just to show you the direction that you're going in with variables and the different contexts that you can see them in. So this would be 10 squared, which is 100, plus 10 plus 12. So all that I've done there is, in this case here, replace the x's with 1s. In this case here, replace the x's with 10. 100 plus 10 is 110, plus 12 is 122. So the answer, if you like, there is 122. So that's one of the contexts in which you'll see variables inside a function. This here is a formula. A formula is just kind of like a function. You'll see the difference between those later on. This is actually the formula that allows us to convert temperature values. So between these two, between C and F. So this would mean that if you had an F value, you put that value in here, and then from that you can work out a C value. But so here the variable, it seems like here we've got two variables, and we do, but we usually refer to the variable that we would be substituting in as the variable and in the variable in the formula, and we tend not to describe this as a variable even though it can vary. So that might be a little bit confusing, but it's just because we're basically putting the F value in here, some numerical value, to work out the C value. So yeah, sure, the C value can vary, but we're really considering it to be a result of letting the F value vary. So there's a little bit of nuance there with variables. So this here, this formula, this is the direction of travel we're going in with the next few classes. So here, the important thing for you is that here you would be able to identify that that F there is the variable. If you allow that to vary, if you allow it to take on different numerical values, and then you work this out, you're going to get a different C value, but that C value is a result of the variability of the F value. So hugely important concept in mathematics, the idea of a variable. If you go on to do all the way through to say pre-calculus and then even calculus in the future, then you will use variables all the time, constantly. So it's like one of those fundamental key concepts to get down now. So that's the idea of a variable. Hope that makes sense. Nothing really to practice here. It's just a case of learning the definition and learning to recognize it when you see it in different contexts.